Quick question. Do your end users always, and I mean always, without exception, work on company-owned devices and IT-approved apps? I didn't think so. So how do you keep your company's data safe when it's sitting on all those unmanaged apps and devices? 1Password has an answer to this question. Extended Access Management. 1Password Extended Access Management helps you secure every sign-in for every app on every device because it solves the problems traditional IAM and MDM can't touch. Check it out at 1password.com/XAM. That's 1password.com/XAM.
Welcome to Heavy Networking, part of the Packet Pushers podcast network of IT engineering shows covering networking, security, and cloud. I'm Ethan Banks, along with Drew Conray Murray. You can follow us on LinkedIn or the Packet Pushers Slack group, which you can join for free at packetpushers.net/community. On today's episode, we cover open source Clabernetes, a tool that allows you to run Containerlab on Kubernetes. Oh, what's Containerlab, precious? I hear some of you asking. From containerlab.dev's landing page, it says Containerlab provides a CLI for orchestrating and managing container-based networking labs. It starts the containers, builds a virtual wiring between them to create lab topologies of your choice, and manages the lab's lifecycle. So the next question you might ask is, why run Containerlab on Kubernetes? There are a few reasons, but I will let our guests explain. Carl Montanari and Roman Dodin, the two people most responsible for bringing Clabernetes to life and keeping it running, join us for today's discussion. Guys, welcome back to Heavy Networking. You've both been on a number of times before, I think. And Roman, I want to direct the first question to you, because before we get into Clabernetes too much, we probably should describe Containerlab to folks. I did a brief intro there of what it is, but would you give us the elevator pitch from your perspective, Roman?
But you described it perfectly because it's coming from containerlab.dev, right? But
yes,
yeah, what Containerlab actually is it's just a simple CLI tool. I think the cool part about Containerlab CLI tool is how you use it. So it allows you to define virtual networking topologies in YAML in declarative format and then spin it up on any compute that runs Docker. So that's basically essentially whatever you use Containerlab for is managing your virtual lab topologies on your personal laptop or your cloud VM or any machine that you have installed Docker on. And I guess what differentiates Containerlab from other network virtualization systems is that you kind of manage your labs as code. And we started to use this term lab as code. Sorry for that, but we just had to. We basically allow you to define your topology as a simple YAML file, and now you have to check it out to Git. You immediately benefit from the Git workflow. And yeah, you can invite your collaborators to work with you on labs. They can contribute to your lab, enhance it, and then you can benefit from everything like versioning, sharing of the labs, collaboration, et cetera, et cetera. Well, I can go on, but I think we would like to dive into the Clabernetes more.
And just to round that out, though, I want to make sure folks understand, with Containerlab, you're running containerized versions of multiple network operating systems. It supports multiple network OSs that are in container formats.
Exactly. So first of all, it's an open source project, and second of all, it's a multi-vendor project. So we support many vendors from like across the board. It's your Nokia, Cisco, Arista, Junipers, Palo Alto, MikroTik, etc. And as you rightfully said, we are spinning them up as containers. But at the same time, we do not require an image to be a native container. We can package a VM image in a container, and then Containerlab will be able to spin it up. So all your legacy systems, iOS XRs, VMXs, Nokia SRSs can happily run in Containerlab setting.
Okay, so I can run a virtualized network OS or a containerized network OS on Containerlab.
Absolutely correct.
It's turtles all the way down, and it's going to get more turtles as we keep going.
Yeah, now that we're bringing Kubernetes into the mix,
sure.
So
yeah,
adding the turtles.
So tell us about Containerlab challenges that Clabernetes addresses, Carl, or maybe putting it another way, why Kubernetes is an infrastructure platform to run labs on?
Yeah, sure. So I guess, Clabernetes really started, a year and some change ago at this point, maybe. I was kind of away from networking for a while, writing Kubernetes controllers. And I was coming back, and I'm a longtime Containerlab user. But now I have this fancy Apple Silicon machine and I have these big topologies I want to run. So these are kind of the two main things that kind of spurred me to say, hey, maybe we can try to put Containerlab in Kubernetes, because with Apple Silicon, I wasn't able to run, most NOSes locally on a Mac, like in Docker on my Mac. And then, of course, you have the scale problem of, okay, great, I want to spin up, 50 nodes or 100 nodes or whatever, right? Something interesting to test, like a kind of real life scenario in CI type system. Generally you're going to need to spread that across some workloads, and you don't want to just keep paying more and more and more to get a bigger and bigger VM from your cloud provider of choice. So basically I said, hey Roman, back to using Containerlab, and what are our options for scaling this out? And he said, well, we've got these other kind of ways we can scale Containerlab out with VMs and stuff like that, which obviously works. But having been in the Kubernetes land a bunch and writing controllers and stuff, I said, well, what if we just stuff it in Kubernetes? And Roman said, you're a crazy person. Let's do it. And so here we are, basically.
Yeah, well, just to add on top of that, exactly what Carl said about the scalability stuff. When you think about Containerlab and the way you apply it, you are quite limited by the virtual scale of your system, right? So you have your VM, or you have your laptop, or you have your cloud instance, and you can grow as high as the CPU and memory of this instance allows you to grow. So you cannot really break out from the boundaries of a single VM. And that was a limiting factor for many, because Carl mentioned scale. And you can imagine if you want to run like a 600 nodes topology, it's quite rare you can find a VM that would fit this lab in. But not necessarily you are speaking about the 600 VMs. Not many of us really need that, but a lot of us need to spin up, like a representation of a core network with 12 core routers. And sometimes the VM-based images, they consume quite a lot, right? So you can name a few vendors who are supplying us with quite beefy VMs. Try to run 20 iOS XRs on your laptop and you will melt it down. So that is when you want to spread it out, right? You want to leverage the horizontal scaling of the compute. And Containerlab is not great at that because it was primarily the personal labbing tool. And you kind of run in the constraints of a single VM or a single laptop compute power. And with Clabernetes, we are kind of lifting up the boundaries by allowing you to scale horizontally.
When you said iOS XR, when you said iOS XR, Roman, that was exactly the image I was thinking of. That thing is such a heavy lift. I think it wants 16 gig of RAM and 8 cores or something like that. It's a monster just to get that thing fired up. It takes several minutes to launch. And if you need several of them, then you need a huge machine to make that thing go.
Yeah, exactly. So that it's not about 600 nodes. Sometimes you really want to spin up a decent lab and you're already out of breadth of your VMs.
But it is fun to say, maybe we can run 600. Just points for that, I think.
the mad scientist option. So when you talk about scaling, so does Clabernetes then let me run very large labs still on, my laptop or one node, or is it more about coordinating across multiple nodes, like multiple cloud instances or something?
Yeah. So Clabernetes is basically stuffing Containerlab into Kubernetes, oversimplifying, but that's basically what it is. So when we deploy a regular Containerlab topology, and I know we'll talk a little bit about clabverter, this kind of plays into this, but when we deploy a regular Containerlab topology into Clabernetes basically slices and dices that topology up and then creates a Kubernetes deployment per node that would have been in your Containerlab topology. So you've got SRL1, CEOS1, IOSXE1, whatever. Each of those becomes a deployment in Kubernetes. And then the Kubernetes scheduler just decides where to put that based on regular Kubernetes things. So there's an assumption you have a cluster. You can absolutely do this on your laptop if you want to test it out with like Docker Desktop or Kubernetes extension thing or Minikube or Kind or whatever. But we expect you to have a Kubernetes cluster. So then
so multiple nodes then.
Yeah.
Okay.
Yeah.
Speaking of clabverter, that was something you had talked about as kind of the precursor to Clabernetes. Is kind of how I understood you to mean it. So tell us about that, because I think it's an important part of the story.
Yeah, so clabverter is another terribly named thing. I keep doing this; it's a trend. Containerlab converter, or that's all it is. But yeah, the idea is it's basically kind of the gateway into Clabernetes. So you have a regular Containerlab topology, and maybe you hit your upper limit of resources or whatever, or you just want to test out Clabernetes. Clabverter is a simple CLI tool that takes your existing Containerlab topology and converts it to a Clabernetes friendly collection of Kubernetes manifests, because everything is Kubernetes. And that sounds pretty straightforward. And at the simplest level, it's absolutely straightforward, because Clabernetes topology literally just embeds a native Containerlab topology in the definition. So that part's really, really easy. But we run into some interesting problems where you have things like bind mounts. And so you want to load a startup config or a license or whatever other files from your local machine. And when you do Containerlab, you can just simply do a bind mount because Docker's running on your machine. Those files are on your machine, and we can put them into the container. Pretty simple. That does not exist in Kubernetes. We don't have bind mounts. We have, volumes and config maps and this and that and the other. So clabverter also tries to, and it doesn't cover every case, but also tries to basically convert things, all the important stuff like startup configs, licenses, into config maps, which can then be mounted to the pods in Kubernetes to make this transition as seamless as possible. It's not 100% for sure, but that's the idea.
And I also remember when Carl introduced me to clabverter, I was like, yes, this is exactly what we need, because people are familiar with Containerlab by now, right? They saw a few presentations, they saw Containerlab.dev website. They still consider this a new tool. And then when I saw Clabernetes, I said okay, Carl, this is very, very new. So we need to have a tool that will guide people from a tool that is new, Containerlab, to a very new tool. And there must be a bridge that is easy for them to cross over. So this clabverter part is exactly what it is. It lets people who are familiar with Containerlab to onboard their topologies to Clabernetes. Because I was thinking, if we let people play with topology custom resources right off the door, lots of them will just, run away with screaming, because that's kind of a bridge too far. So we needed to have a tool that would let them simplify their transition if they need to run this massive lab or a lab with lots of beefy VMs. I would like them to have the best experience by just taking the topology of Containerlab and with clabverter tool convert it to Clabernetes constructs. And I think that's the beauty of clabverter, because it makes it so much easier to get started playing with Clabernetes.
So if I'm understanding then correctly, if I've built some topologies in Containerlab, but this Clabernetes sounds interesting, I can use clabverter to take those topologies and get them into Clabernetes to get me sort of up and running more easily on Clabernetes instead of starting from zero.
Yeah, absolutely correct. And that is exactly what Carl was alluding to by saying things that run natively with Containerlab, like bind mounts, startup configs, environment variables, we needed them to be converted to Kubernetes native constructs. And without you having to bother, how do I get this file that is my startup config for my SR Linux and move it to a config map in Clabernetes, clabverter will do that for you. Carl, sorry, I cannot even spell clabverter and Clabernetes in the same sentence. My tongue is twisting. So clabverter does that for you, because otherwise you will have to do this manually. And that's probably not the best user experience that at least I envision. And for sure, when people get more and more familiar with Kubernetes constructs and they understand how the whole machinery works, maybe then they will just abandon clabverter and start to modify the Kubernetes constructs directly.
Carl, there's another project out there called K&E I've run into, Kubernetes Network Emulator, I believe. Is Clabernetes anything like K&E? Are they related at all, or?
No relation, other than doing similar things, of course. I think both of their goals is to run network topologies in Kubernetes, of course. I created Clabernetes because the user experience for Containerlab is just really, really good. It's really easy to get going. I've done a fair amount with K&E. It was a little bit more of a steep lift, I think, to get into. I think probably it's like a technically better solution. I'll be totally honest. And, you know, we can kind of talk about that as we talk a little bit about how Clabernetes works. But yeah, I mean, I think for me, Clabernetes, the main thing is it's way more support for all the NOSes out of the box, because it's 100% of what Containerlab supports, we support.
Right.
And yeah, just like very low barrier to entry. I mean, of course, there's Kubernetes, so there's a barrier to entry. I'm not trying to say there isn't, but it's definitely a lot less than K&E. So similar things in the end. I'm biased, of course, because I made Clabernetes, and I've been a big Containerlab fan for a long time. But yeah, they'll get you similar places in the end. But
there's also one specific aspect that kind of made Clabernetes way easier for us to integrate with is K&E runs containers natively on Kubernetes. And the model that they use is a controller that manages a particular vendor. And it's probably the most straightforward approach, the most Kubernetes native approach. What we wanted to do is we wanted to leverage already supported Containerlab kinds. So we wanted to leverage all the work that has been done in Containerlab land and reuse it in Clabernetes. So we did not want to reinvent or redevelop controllers for each particular kind, because we just don't have bandwidth for that, right? And instead, we wanted to make sure that whatever we already invested in on Containerlab side, we can just move it over to Clabernetes. And that is why when we go into the weeds of Clabernetes, you will see that it actually runs and orchestrates multiple Containerlab topologies. So we wanted to make sure that what we invested already, we get benefit from it.
The simple, obvious one is you just want to have a topology and it's too big for your laptop. I did a talk at RIPE 88 with Simon from OVH. So that was his talk. I just participated. But his basically, he's using it and OVH is using it, Clabernetes, to basically emulate their big swaths of their network for part of their CI process for pushing changes and config updates and things like that, so that they can emulate like a serious chunk of things instead of just, one or two nodes. They can emulate like a whole region, and then be able to validate, within reason. Of course, it's not one-to-one with real life with hardware versus software. All of these things, we can't be perfect, but you can be pretty good. And so that they're using that as part of their CI pipeline. So I think that's probably one of the coolest use cases. And I mean, Scrapply and other projects have been using Containerlab in CI for like a long time at small scale. And that's great for unit testing these libraries. But when you start to go to talk about testing like a whole network, obviously it's a little bit more difficult, especially when you have these small runners, things like that. So yeah, I think that's probably the main kind of gist of it for use cases.
So when I was thinking about labbing, I was thinking about, I've got an exam coming up and I want to actually get some hands-on, but it sounds like there's more elaborate things that can be done here than if people are actually using it, for testing and actually kind of mirroring production.
Oh yeah. I mean, you could definitely use it in Anchor for sure. There's of course, like the first use case is exactly what you say, of course. Right. But, now that we have the ability to run these, XRVs that take a lot of memory, and we can have 20 of them or 30 of them, how big of your cluster is, you can start emulating like a really big chunk of a network. And then maybe you're pushing configs, in kind of sets per region or per AZ or whatever you want to call it. And now you can reasonably faithfully, emulate that. And I don't want to say digital twin because because I don't want to say that.
It was going to come up, but I appreciate you doing it now and discounting it. Yeah, we're not there yet.
Yeah. But yeah, that's the idea.
Yeah, I was about to throw in digital twin because I think that is actually what it can do, right? And like the example that you gave with Simon and OVH is a prime example that we witnessed. So companies that already have Kubernetes clusters in their vicinity, in their companies, they now can leverage that from the networking perspective. They can run the networking topologies using the compute power that their IT teams probably manage. So it's not that the networking folks really have to uplift the Kubernetes stand-up orchestration, maintenance of the clusters. They leverage the IT department and their workforce who does that for deploying applications or whatnot. And then they just kind of onboard the networking part there. And we have OVH for one, and then there's another company more on the payment side in Europe they started to use Clabernetes again for testing and validation of their network, because for them, it's super easy. The IT team provides them with a namespace in Kubernetes and then can run topologies there. They don't have to provision VMs. They don't have to bother with user access. It's all already done for them. And I guess that is something that we anticipate we will see more and more in the future. Kubernetes will be a de facto platform for compute that we as network engineers will get from the IT teams. And it's just like, in our case, another way to deploy networking topologies over. And the beauty of that is that we do not have to forklift the stand-up of the clusters. We don't have to operate them. Of course, if you have IT teams who does that for you. But sometimes, yeah, that is exactly the case with bigger or medium-sized companies. They operate that way.
Let's pause for a message from today's sponsor, 1Password. Imagine your company's security is like the quad of a college campus. There are nice brick paths between the buildings. Those are the company-owned devices, IT-approved apps, and managed employee identities. And then there are the paths people actually use, the shortcuts worn through the grass to the actual straightest line from point A to B. Those are the unmanaged devices, shadow IT apps, and non-employee identities like contractors. And most security tools only work on those happy brick paths, but lots of security problems take place on the shortcuts. 1Password Extended Access Management is the first security solution that brings all these unmanaged devices, apps, and identities under your control. It ensures that every user credential is strong and protected, every device is known and healthy, and every app is visible. 1Password Extended Access Management solves the problems traditional IAM and MDM can't. It's security for the way we work today, and it's now generally available to companies with Okta and Microsoft Entra, and in beta for Google Workspace customers. Check it out at onepassword.com/XAM. That's onepassword.com/XAM. And now back to the podcast.
Now, this next question's a stupid question, but I'm going to ask it anyway, because I already know the answers. It depends, but I'm going to ask it anyway. What would you say the recommended spec is for a case cluster to have a good Clabernetes experience?
One that you don't have to manage, one that somebody else is managing. That's the, no, I mean, really it runs on whatever. I run like on Debian, Proxmox VMs, Debian VMs on Proxmox with just vanilla K8s at home. We've got people running this in GKE and EKS. The node pools and like the actual node sizes are going to obviously depend. Hate to say that too. They're obviously going to depend upon what type of NOSes you want to run and what the footprint of those NOSes are. I think like in general, your kind of vanilla, whatever nodes you get in your node pool from your cloud provider is probably okay. But maybe if you have a very greedy NOS, you need to try to talk to your Kubernetes people, or if you manage it to get a node pool that has some heavier duty compute. So, of course, no good
You're
answers.
going to notice when we bring this lab up with all these iOS XR images in it that the cluster almost comes to a halt. It's going to be okay, though, because once they're fired up, it's not so bad.
5 degrees warmer. What's going on? Yep.
Now, you mentioned EKS, AKS, and so on. We're okay running Clabernetes in the cloud on those Kubernetes as a service offerings?
Yeah, generally. In general, Clabernetes should run in any cluster. There's a huge asterisk with that because, of course, there's like a gazillion different knobs and widgets and flags and whatever. We've run it in GKE. Roman's doing crazy stuff in like a cluster on OpenShift because he's a madman. Like I said, I've got vanilla Kubernetes at home. We've got somebody reporting good success in EKS. OpenShift has been proven to work. So like all of these should work. Sometimes you'll have some kind of caveats to that, like, oh, well, you need to use this flag in Clabernetes or something like that, or you have to enable this feature in your cluster. But generally, it should work anywhere. Yeah.
Then, of course, you can just use your standalone clusters that you deploy yourself. Like, let's say you have a bunch of stale compute, your old dusty supermicros, and they can form a nice cluster so that you can just dust them off, run Talos on them or K3s, whatever you have, form a cluster with them. And even though each single VM or hardware unit had maybe 16 gigs of RAM, if you have 10 of them, that's already 160. So that's a decent sized cluster. So you can run quite beefy topologies on it. So not necessarily you immediately forced to go into the cloud. You still can, like Carl just said. But if you just have a bunch of computes, nowadays with all the tooling that's there in the industry, you can spin up clusters on bare metal compute just as easy. So don't run scared away from hardware. You can still install Clabernetes and Kubernetes on it.
Yeah, and I know, Ethan, you were going to ask about Kate's version. So anything 124 and up. And the only reason that we need that is because we do, I forget, there's a feature flag name, but it's a service that can have TCP and UDP ports on it, multi-protocol service or something like that. But 124, you should absolutely be on newer than that. So it shouldn't be a big deal.
So you mentioned you've got users who are having the DevOps folks or the IT side of the house install Clabernetes or install the Kubernetes infrastructure to run Clabernetes. If I don't have that and I am new to Kubernetes, do I have a shot at installing this?
Yeah, of course. Especially if you have a cloud and you have enough power in the cloud to ask for a cluster from your cloud. That's definitely the easiest path. But you can, like I said earlier, you can do Docker Desktop with the Kubernetes thing on your laptop if you just want to test to see, hey, is this something I'm interested in? But yeah, after that, the next easiest thing is ask your cloud provider and have them give you a cluster. That's definitely the easy button. Because otherwise, obviously, then you got to deal with spinning up a cluster, which you could, of course, do, but more steps involved.
Now, labs, we've been joking about the super beefy. Some of these VMs and containers can be massive. So, if I'm configuring some of this for Kate's, are there parameters that I'd be writing into Clabernetes YAML or something to try to keep the lab from absolutely killing the cluster? Or is it more like, I know this container is a monster that I'm about to deploy and I gotta, just kind of allocate resources appropriately?
Yeah. So there's two main ways that you can deal with this in Clabernetes. And you can set at a global kind of config level, limits and requests based on the Containerlab node type. So like SR Linux, for example, or Cisco or IO6E or whatever. And you could say like, here's the maximum resources you're allowed, and here's the minimum needed for scheduling. And these are just like regular Kubernetes resource configurations. Then you can also do that on a per topology basis in Clabernetes. And so obviously you can kind of like override the global configuration on a per topology basis if you're like, wow, this one's really important, let's give it more resources, or something like that. At the end of the day, this is vanilla normal Kubernetes resource stuff, and we just happen to be exposing it in Clabernetes basically.
And I think that is really cool because like not all people understand like why exactly we do Clabernetes or Kate's stuff here, because if you think about how would you spread compute? How would you spread workload on different compute? That's a challenging problem to solve. Because when we initially wanted to horizontally scale Containerlab, that is something that we would have to write code for. We would have to analyze how many CPU and RAM each particular node has. Can we schedule a Containerlab node there or not? Mm-hmm. Kate's does that for us. So we don't have to deal with that. We just say this node, be it Nokia or Linux or Arista COS or something else, consumes, let's say, 2 vCPUs and 4 gigs of RAM. Now, this is a static setting for a particular kind of the topology. And then Kubernetes is smart enough to figure out, okay, now I have 8 worker nodes. 7 of my nodes are pretty busy, but 1 is free. So I can schedule this node on my 8th node, which is free. And this kind of smartness is absolutely critical when you want to run, and I will say it again, digital twins, or run labs that are more critical than just your, regular development lab. You want this to be spread across. You want to leverage your compute that you have in your possession. And Kate's does a great job at scheduling workloads on top of horizontally scaled computes. That's why we definitely would want to use these powers to, power our labs.
Well, you're talking about things that Kate's does inherently. That's what it's there for. It's a scheduler. It is constantly going through a loop to make sure that the state of the cluster is as has been defined in all of the YAML that has gone out there for application deployments. So in the case of something like the one node of the lab crashes, does Kate's restart it and it rejoins? Does it do something like that? Because a lab is like one big entity and there's a bunch of tunnels interconnecting them and so on under the hood to make them all work. So it feels odd as opposed to the standard Kate's deployment of stateless containers. And we spin one up and if it dies, it dies. We make another one and it's fine. And there's a lot of plumbing that you don't think about, don't have to worry about. This feels different because there's all these dependencies.
Yeah, I mean, I would say it's still similar to like a normal Kubernetes thing. If one of the nodes in the lab does die, it will of course get rescheduled. And then the connectivity between the nodes is all done based on service. So, there's no like, well, we got the IP of that pod and now we need to, connect to it and things like that. So everything's done based on service lookup. So it's like a cluster IP, and then we connect on that on the VXLAN tunnels between all the things to spin up the links. So, there may be some hiccups, of course, like obviously, especially because like the boot time for some of these nodes is like an eternity. So that doesn't help. Yeah. But in general, it should just work. I think that's like a really common kind of thread for Clabernetes is, do smart stuff stupidly or stupid stuff smartly, and like just try to let Containerlab or Kubernetes do as much stuff as possible and just kind of get out of the way of these things and let them do what it is that they're good at. That's like kind of the main like design philosophy for this is like, we love Containerlab. Just do Containerlab, just scale it out. And well, why are we doing Kubernetes? Well, because it already does all of this junk. So like, why would I try to, reinvent that wheel? Like let Kubernetes do its thing. So, hopefully it all works. Well, we know it all works, but sometimes there can be some hiccups, of course.
So let's, I guess, peel the onion a little bit. In Kubernetes land, there's the notion of the pod, which is like the smallest addressable component. It's where containers run. Can you kind of walk through what's happening inside that pod when a lab node is being fired up?
Yeah, for sure. So when you create the topology, our controller, just a fancy word for some Go code, sees that topology, divides that topology up, the Clabernetes topology, which contains inside of it the Containerlab topology. We're already into the turtles. We then say, okay, you've got SRL1, COS1, and whatever other nodes in your Containerlab topology. And for each of those, however many nodes you have in the Containerlab topology, we spawn a Kubernetes deployment that has, as you say, inside of it, a single pod. Inside of that pod, we're running an image that we call the launcher image. And this is like a Debian image, pretty simple standard stuff. Inside of that image, we run a Docker daemon because we need Docker for running Containerlab, of course. And then we, by various means, get the image that that particular node is, like COS 4 dot whatever, who cares? And we get that image into that Docker daemon, and then Containerlab can go ahead and spin up a topology. The only difference is this topology is a single node, but it's still a valid Containerlab topology. Once the Containerlab topology has booted everything, we then use Containerlab tools to spin up VXLAN tunnels for all of the links that particular COS1 in this case cares about. It's trying to talk to SRL1. Well, on E1 to E1, whatever, we spin up that VXLAN tunnel using Containerlab tools, which is just invoking like regular IP command stuff to spin up VXLAN tunnels.
And again, I don't see the VXLAN tunnels. Yeah.
It's a lot, but it's like overly simple. It's overly complicated and simple at the same time, I think.
Yeah, I think what I read from this, if I would listen to this for the first time, is that if your Containerlab topology has 3 nodes, when you convert it to Clabernetes, you will have 3 pods. Each pod will be a single node from your Containerlab topology. Whatever you had as links in your Containerlab topology would be a VXLAN tunnel between the pods or in Clabernetes. So kind of 3 pods separately deployed on different compute will be stitched together with point-to-point tunnels through the VXLAN that Clabernetes controller sets up for you. So that's kind of how the decoupling works in our case.
And as the lab user, I'm not going to see the VXLAN tunnels. I don't care. That's all under the hoods. Under the hood, what I see are 2 switches that are interconnected on whatever links I provisioned. It so happens that interconnectivity is happening through a VXLAN tunnel across nodes or cluster members within the case cluster, but it doesn't matter to me.
Yeah, exactly. Show LLDP neighbors. It's there. It's all just normal stuff. Yeah, exactly.
And at the same time, you have the same Containerlab experience. So if you connect to the pod, you see a VM. Well, it's a pod, but it's kind of a VM. You can do Docker PS and you will see a container. You can do Containerlab inspect and you will see a lab as if you would run it on your laptop, So it's kind of the same user experience, just spread it across the K8s managed cluster. And that's why Carl likes to keep it simple and stupid. It's basically simple, but it's kind of smart.
in a really dumb way. But it works, and I think that's job one. You know what I mean?
So just so I understand then, you're going to have containers that are up and running in this cluster with connections between them established essentially by Kubernetes, and that's kind of a topology. And then on top of that, I'm building my virtual topology for my lab to do the things I want to do. So there's, again, the turtle issue. There's kind of multiple topologies running here. There's the actual one connecting all these containers, and then there's the labbing one that I'm working on.
So the first one that you said, the Kubernetes one, that's just normal pod-to-pod communication. There's no extra tunnels. That's just regular Kubernetes stuff. But then, inside of that launcher, there's the container that is SRL1, COS1, and then there's the VXLAN tunnel. And that just rides on top of Kubernetes like a regular, whatever regular traffic that's riding on top of Kubernetes would look like. It's from a Kubernetes perspective, it doesn't matter at all, right? It's just traffic. It happens to be going between pods. That's fine, but it doesn't really matter to Kubernetes. But obviously, it matters a lot to us because that's what's plumbing, our lab together.
Okay, and that is why when Carl was saying that if pod dies and it gets rescheduled, because it's all decoupled, the services stay intact. Only the pods gets rescheduled on another compute. Then it will set up the same tunnel to the same cluster IP, so that from the topology perspective, nothing happens. Topology stays as it was originally deployed. It's only the pod that moved to another compute, but then the service will be reestablished to the same cluster IP, and eventually you will have LLDP working between the nodes. So it's kind of quite nice to see that the topology kind of goes back from piecemeal to working state again.
I guess I'm just wondering if I'm working in my lab and for some reason I'm not seeing traffic flowing where I'm expecting it. Is that a problem with my lab, or is that a problem in the Kubernetes underlay, and how do I figure that out?
You just got to pack it up and burn it all to the ground if that happens. Kidding, obviously, but not. It can be a pain to troubleshoot this. When it works, it's beautiful, and troubleshooting it can definitely be a little bit much because obviously there are a lot of moving pieces. None of them are particularly complicated, but there are a lot of moving pieces moving together. So yeah, if you do want to troubleshoot it, that definitely opens up a bit of Pandora's box, but getting onto that launcher pod and doing some TCP dump stuff, that's kind of the first way to do it. You should be able to see something and then probably come back to Discord and we could figure something out. We've probably seen it. We've probably broke it in that way already. But you should be able to see that VXLAN traffic coming in or out, or at least one of those, hopefully both. Obviously, if you have both, it's probably working and you're not doing the TCP dump. But that's basically the kind of troubleshooting path is TCP dump and figure out what's not going out or coming in, and, where you're losing stuff. But it can be a pain, but hopefully it just works.
Is there anything special that you had to do to support multiple connections going in and out of a node for Containerlab? Because you've got a switch with multiple ports doing interconnections to multiple things, as opposed to a more typical Kubernetes scenario of a service that's probably being exposed on a port. Yeah,
so I think this goes back to why we have this launcher thing, because in normal Kubernetes land, you have ETH0 or whatever your first interface is, and that's the one Kubernetes manages, and that's all it cares about. And then you have something like KNE, which had, at least for a time, I don't know if they still require it, had Multis for a secondary CNI, which is then managing all of these additional Ethernet interfaces because Kubernetes doesn't care. So you need the secondary CNI. Well, we didn't want to do that. We didn't want to have users have to install a secondary CNI. So to get around this, we were stupid smartly, and we stuffed everything into another container, and then we ran the tunnels from inside that container, because then it's just Docker and it's just VETHs and it's just whatever normal stuff same stuff that you do in Containerlab on your VM or your laptop or whatever. So we basically totally just paved over that problem with our launcher pod.
Yeah, I think that's actually one of the greatest questions around Clabernetes. Like, the way we set up tunnels is our way to solve the problem of secondary interfaces. As you said, Ethan, in Kubernetes, ETH0 is a king. That's the only interface, and people just care about that in the application land. With networking, ETH0 is management, and people don't care about it at all. All we care about is the data path interfaces. And to set up these tunnels, you can either do Multis, like a CNI that has an ability to set up tunnels from different interfaces, or you can use different CNIs that do this thing. In our case, we knew that installing a CNI on a cluster is a pain. And it's a pain because you cannot install CNI sometimes in clusters that you do not manage. And we wanted Clabernetes to run on public clouds. So we said, well, yeah, probably Carl said that, and he just told it to me then. We want to have our solution without a requirement that you need to bring your own CNI. That is why setting up tunnels from the pod is beneficial, because you don't really care if you have Cilium CNI or Flannel or something else. It doesn't really matter. We just set up a legitimate traffic from a pod to a cluster IP. It can be whatever. Kubernetes cluster doesn't need to know what we are, pushing through the pipe. And that is why we kind of have the ability to create these tunnels, as many as we want, without having the requirement to run a specific CNI.
With the fun caveat that we use a non-standard VXLAN port, because I think it was Cilium or Calc, one of the Cs, that was very upset about allowing VXLAN traffic from pod to pod by default. So non-standard VXLAN port, but other than that, it's just vanilla VXLAN.
So is there a limit on how big I could scale a lab on a case cluster, assuming I had infinite hardware available to me?
It's a hard one to answer because I have no idea. In theory, sure, it could just keep going. I think the biggest reported topology we've heard is like 100 COS devices, and apparently that was no problem, which probably is a pretty good indicator. I mean, there's no like technical reason, right? Because probably the VXLAN tunnels will fall over because it's all in, that's like probably the weak link because there's a bazillion services and just stuff's going to break. But yeah, I mean, you can obviously have thousands of pods in a cluster. So in theory, we could keep scaling. I think it would be interesting. It should work.
The limiting factor would be storage or something that you run out of, like etcd capacity or something like that, but not inherently something that Clabernetes imposes on you.
Okay.
So people should try it. Tell us. See where it falls over. Let us know, because I don't have enough compute to do this. So.
But the glove has been thrown.
Yeah.
Right.
So how do people get a hold of Clabernetes?
So we've got the docs living in the Containerlab docs because it's obviously very tightly coupled to Containerlab, so they live there. So you can go to containerlab.dev. There's a whole Clabernetes section. Roman did all the beautiful docs. I did no part of that, so this is all to Roman's credit. But there's a quick start guide for how to do it. One thing we didn't talk about is you probably want a load balancer for your cluster. So Roman even added like installing kubevip and getting that going so that you can access your nodes just via SSHing to like a public IP. And then the installation of Clabernetes is Helm. Love or hate Helm. It's kind of common standard thing. So we just rolled with that. Pretty simple, one line install for anyone that wants to install it, assuming you have access to the cluster. You will need some pretty elevated privileges to install, because we have to install the CRDs. But once you have that, you should be able to live within a single namespace and have no extra cluster privileges. So I guess that was another thing we didn't really talk about, but it's probably relevant for people trying to get started. But yeah, Helm chart and everything's hosted on just GHCR or GitHub Container Registry, whatever that one is. Too many acronyms. Right. So it's an OCI chart, and then the launcher image, the manager image, they're all there. So it's all public, easy to get to.
Things that if someone else is managing the case cluster for me, I can just point them to this. They're going to be very familiar with this, know what to do, get Clabernetes, the CRDs and so on. Everything will be installed and ready to go. They could set up the namespace, set up permissions, and then turn it back over to the network folks and go, yep, you're all set to go, guys.
Yeah, totally. Like this is, if you're living in Kubernetes land all the time, like looks pretty normal because it's just normal stuff. There's nothing crazy going on.
And I don't know if we've said it, but it's all open source as well. So there's no secret source anywhere. You can look at the code. The controller is open source. And of course, the Containerlab part that is chugging underneath it is open source. So people are free to dive in and see how it all works. And I think we also did not discuss the additional networking linking thing that you created, because we don't have, we not only have VXLAN, but we can also support TCP-based tunnels, and sometimes it helps. Some clusters are peculiar in a way that they allow you to push VXLAN traffic in the K8s cluster. So Carl was crazy enough to write another tunneling technique based on TCP, so people can use that. And some of our initial users or alpha users said that this stuff helped him to overcome some specific issues in his cluster because he couldn't run VXLAN tunnels for one reason or the other. So people would want to try this as well if they see any issues.
They just want to see the logo, though. Slurpee, another badly named thing that I made that I cobbled together in a caffeine-induced rage. I don't know, but the logo is pretty sweet. So,
and just to kind of close the loop on getting started with Clabernetes, I think when I started to pick the brain of Carl and see how I would explain Clabernetes to myself, and I started to write quick start docs like with this thing in mind, I wanted to make sure that everybody has a smooth start. So if you want to start with Clabernetes, there is a quick start that goes around how to install kind cluster. I was thinking about network engineers specifically, right? I know that people who are on the application side, they know how to install kind with their eyes closed. When you go to networking folks, you want to kind of chew it on and make sure they understand how to get from A to Z without gaps in the story. So you will have a quick start that explains it all, from installing a kind cluster, installing a load balancer, explaining why you need a load balancer, explaining how to connect to the pods, how to use kubectl. So all these things, we kind of try to make them as clear as possible, because otherwise it's easy to fall into the, a gap of understanding it all or having the baggage with you. But not everybody understands Kubernetes concepts. But still, we think that it is quite interesting for network engineers to look at this space and maybe try and launch their IOSXRs or, VMXs there and see how it runs. And as well, they will learn Kubernetes, which never hurts. We kind of think that in the long run, you will see K8s more and more penetrating to network engineering domain.
Really, if you're going to be working in cloud. So yeah, I think that's a good promotion for getting into Clabernetes. Carl, you mentioned Discord. Is there an active community out there that folks can tap into if they have questions or run into problems?
Yeah, we have a Discord channel. We're just on the Containerlab Discord, but there's like a dedicated Clabernetes channel. Yeah, that's probably the best place.
Yeah, and we have some users already there exchanging ideas, solving issues. So it's kind of a vibrant community. I was surprised to see some initial uptake because the tool is new. And yeah, still we have quite a lot of folks who are quite interested in that.
And I looked at the quick start guide, Roman, just to note that too, and it does look pretty detailed. So yeah, if you are feeling a little intimidated, there's really good support available for you.
Well, guys, great show. Carl, you pinged me. Hey, you want to talk about Clabernetes? Like, sure, let's do that. So great conversation. Now, Carl, if people have follow-up questions for you, how do they reach out to you?
That's difficult. I've fallen off the internet, I think. No, I am in the Discord. I try to be helpful there from time to time. I'm still lurking on Twitter. I don't know why anymore, to be honest. And I guess I'm on LinkedFace, although I don't log into that either. So I guess Discord is probably the best bet.
Carl, the contrarian. He's not social anymore. Okay, fair enough.
Roman,
what about you?
Yeah, I'm still hanging on Twitter, so people can find me there as NTDVPS. And I'm also active on LinkedIn by my first name and last name. And yes, I run this Discord channel, so there's lots of ways you can reach out to me.
Twitter, you're still there. I've forsaken it. I'm pretty much over what's going on over there in Xland. But serious question, Roman. There's still some good tech Twitter happening these days?
That's probably the hardest question of this talk. It's really, I think it's diminishing, to be honest. I think there is some folks still hanging out in Twitter, and some of them are not on LinkedIn. So we have kind of disjoint communities. But yeah, I think nowadays LinkedIn is winning over the tech community, social media.
Yeah. Yeah, that's been our experience. LinkedIn seems to be the place where a lot of good threaded conversations are happening, lots of comments, and then people you follow or are connected to who get into an interesting conversation that can pop up in your notifications and make you aware that, oh, there's something interesting happening over here, and you can hop over and check it out. And it seems like they got the algorithm pretty well sorted, and I don't see a lot of angry politics, and there's no spam bots following me and other stuff on LinkedIn. The occasional recruiter, the occasional SEO specialist who wants to help me with my website, but other than that, the spam, the signal to noise is pretty good over on LinkedIn
Sounds
right now. Yeah. All right, everyone. Thank you for listening to Heavy Networking today. Now, I've been watching virtual labbing evolve since the early days of GNS3, and now we've got EVE-NG and Containerlab and NetLab and Cisco Modeling Labs and all these other tools for lab enthusiasts to find their way into the world. And I guess what intrigues me the most is the potential to build a reasonable facsimile of your production network, but entirely virtualized. And Clabernetes shows that you could build a pretty large lab indeed, scaled across a K8s cluster. Now, I suspect most of us use labs because we're doing proof of concept testing. We want to learn something for certification. We're going to test an automation we're working on. We're going to write a procedure, that kind of thing. But I think where we're heading as lab tech evolves is running a proposed production network change against the lab as a required validation step. And it's all integrated in a pipeline. And a lot of that tech exists today. There's, I think, people that are really mature in their automation practice are already doing that. And maybe the only trick is whether or not you can get the lab image of all your network devices to run in a lab. That's still a thing because not all vendors are on board with containerizing the operating systems and stuff. There's some commercial tools too that if you're willing to pay for them, and they are egregiously expensive in a lot of cases, you can emulate your network in that way as well. So we mentioned digital twin along the way, and everyone was like, I don't want to talk about digital twin because, yeah, it's marketing has abused that term. But what we're getting at when we say digital twin is a virtualized version of your network off to the side that you can manipulate this thing. You can run tests against it and so on. But the fact that we all went, when digital twin came up, yeah, be aware that digital twin means different things to different companies depending on which marketing department is telling the story. And not all digital twins, so-called, are the same tech. But we're getting to the point with a reasonable time investment, you can build a useful, maybe not full featured, but a really useful digital twin yourself. And I think the conversation we had today with Carl and Roman gives you an example of how that might happen. I've been Ethan Banks with Drew Conray Murray. You can connect with us on LinkedIn or join the Packet Pushers Slack at packetpushers.net/community. Lots of other engineering-focused shows in the Packet Pushers lineup. We cover not just networking, but also cloud, security, strategy, and leadership. You can find it all at packetpushers.net or just punch Packet Pushers into your podcast app. Last but not least, remember that too much networking would never be enough.